We have practiced combining like terms and reviewed the rules of exponents, so we are ready to multiply polynomials. We're going to break it down into 3 cases in this video: monomial times polynomial, binomial times binomial with FOIL, and finally polynomial times polynomial. All of those cases are ultimately based on the distributive property, and that's what we think about when we multiply a monomial, one term, times a polynomial, several terms. Apply the distributive property and follow the rules of exponents. So we have the monomial, negative 2x squared, times the polynomial, or trinomial, 3x squared minus 5x plus 4. To execute this multiplication, we're going to distribute that monomial to all 3 terms of the trinomial. So we have negative 2x squared times 3x squared. That gives us negative 6x to the 4th. Now remember, when we're multiplying like bases, we add the exponents. So when executing x squared times x squared, I'm thinking x to the 2 plus 2, or 4. Then we distribute negative 2x squared to the second term. Negative 2x squared times negative 5x gives me positive 10x to the 3rd power, again adding exponents. And then finally, negative 2x squared times positive 4 gives me negative 8x squared. Our polynomial here is in descending order, or standard form, so we are done with the multiplication. Next, we'll consider the case binomial times binomial. In the case of binomial times binomial, we're going to use what we call the FOIL procedure. FOIL is just an acronym for remembering the order of terms that we're supposed to multiply. When finding the product of 2 binomials, use the FOIL method. FOIL is an acronym that stands for first, outside, inside, and last. Let's examine what this looks like on an example. So suppose we have the binomial x plus a times the binomial x plus b. So what we're going to do is multiply each term in the first position from each binomial. That is x times x to get x squared. Then we're going to multiply each term in the outermost position of each binomial. Now, if b is a number, x times b would be bx. We always put the coefficient there on the left. Then we're going to multiply our inside terms. Our innermost terms here are a and x. A times x gives me ax. And then we multiply the terms in the last positions. That's going to be a times b, or ab. Also notice all 4 of our terms are separated there by a sign. In this case plus, but it could be a plus or a minus. Oftentimes when you FOIL, you're going to have like terms for your 2 middle terms, and you'll need to combine those terms. Okay, let's practice FOIL on the following examples. Find the product of the following binomials and write the result in standard form. So we have the binomial 2x plus 3 times the binomial 5x minus 4. So we're going to begin by multiplying our first terms together. 2x times 5x gives us 10x squared. Then we'll multiply our outside terms together. That's going to be 2x times negative 4. That gives us negative 8x. Then we proceed to our inside terms. That's 3 times 5x to get positive 15x. And then we multiply our last terms together, 3 times negative 4 to get negative 12. Notice our middle terms are like terms. They have the same variable parts. So when we simplify, we have 10x squared for our first term. Negative 8x plus 15x gives us plus 7x. And finally, we have constant term, negative 12. Observe that the product of 2 binomials gives us a trinomial. Okay, the next example is a special pattern, but you don't have to know anything about this special pattern to execute the multiplication. So let's see what happens. When we multiply our first 2 terms together, x times x, that gives us x squared. Then we multiply our outside terms together. X times negative 5 gives us negative 5x. Multiplying our inside terms together, 5 times x, we get plus 5x. And our last terms, 5 times negative 5, gives us negative 25. Once again, our two middle terms are like terms, but they're opposites, so they're going to cancel out. And we just end up with x squared minus 25. X plus 5 and x minus 5 are what we call conjugates. When you multiply conjugates together, the outside and inside terms always cancel, and you end up with a binomial, which later we'll learn is the difference of two squares. Okay, for our last example here, you want to be really careful. As we discussed in the previous video, I cannot distribute an outside exponent across a sum or a difference. I can only distribute an exponent across a product or a quotient. So in this case, when you have a binomial squared, take a step to expand that exponent. 3x minus 4 quantity squared means 3x minus 4 times 3x minus 4. Then it's clear that we should FOIL those binomials. So multiplying our first two terms together, 3x times 3x gives us 9x squared. Multiplying our outside terms together, 3x times negative 4 gives us negative 12x. Inside terms, we have negative 4 times 3x, which gives us negative 12x. And multiplying our last terms together, negative 4 times negative 4 gives us positive 16. Now, unlike the last example where our middle terms were the opposite, when you square a binomial, your middle terms are going to match exactly. When we combine like terms, we have 9x squared minus 24x plus 16. So that's the FOIL process. Now, if you look at the FOIL process, all we're really doing is distributing the first term to each term of the binomial and the second term to each term of the second binomial. That's the overarching principle when we multiply the more difficult case polynomial times polynomial. Here's the procedure. Systematically distribute each term of the first polynomial to each term of the second polynomial. So on example 5, we want to find the product of the following polynomials and write the result in standard form, which of course means descending order. So what we're going to do on this one is begin with that first term. So I'm just going to look at the first term of the first binomial, and I'm going to distribute that to each term of that trinomial. So we're going to end up with x times 3x squared, which is 3x cubed, minus x times 2x, which gives us negative 2x squared, and then x times 1, which is just x. So the first term of the first binomial has been distributed. Then I'm going to move to the second term, negative 2, and distribute it to each term of that second trinomial. Negative 2 times 3x squared gives me negative 6x squared. Negative 2 times negative 2x is positive 4x, and negative 2 times 1 is negative 2. Then we combine like terms, starting with our highest powered term. So our highest powered term there is 3x to the third power, and it doesn't have any matching powers, so that'll be our leading term. Then we'll combine our x squared terms. Negative 2x squared minus 6x squared combines to give us negative 8x squared. We'll combine our x terms. Plus x plus 4x gives us plus 5x. And then our last term there is minus 2. So we did binomial times trinomial, and we ended up with a 4-term polynomial. Let's try that again on the next example. So again, I'm going to take the first term of my first binomial and distribute it to each term in that second trinomial. We have negative x squared times 4x squared. That gives us negative 4x to the fourth. Negative x squared times negative 6x gives us positive 6x to the third. And negative x squared times 7 gives me negative 7x squared. Then, once we finish distributing the first term, we're going to proceed to the second term of our binomial and distribute that to each term in our trinomial. We have negative 1/2 times 4x squared. Negative 1/2 times 4 gives me negative 2x squared. Then we have negative 1/2 times negative 6x. That's going to give us plus 3x. And negative 1/2 times 7 gives us negative 7/2. Next, we're going to combine like terms and write it in descending order. So we start with our highest powered term, which is negative 4x to the fourth, and it doesn't have any matching terms or like terms. Then we look at the next highest power of x, which is x to the third power. It also does not have any like terms, so that'll be our next term. And then notice we have negative 7x squared minus 2x squared. That combines to give us negative 9x squared. We have the term 3x with no other like term. And finally, our constant here on the end, negative 7/2. Okay, so again, the principle is to multiply every term in the first polynomial by every term in the second polynomial. One more example here, we have 2x minus 3 to the third. Be really careful here that you understand we are not distributing the exponent. Like we did with our squared binomial above, let's rewrite this as 2x minus 3 times 2x minus 3 times 2x minus 3. Then we're going to take it little by little. I'm going to begin by multiplying those first two binomials together. And when we do that, we can use the FOIL process. Once I find that answer, I'm going to need to multiply it by this last binomial. So for now, I'm going to keep the result of this FOIL in parentheses. So multiplying our first two terms together, 2x times 2x, we get 4x squared. Outside terms give us a product of negative 6x. Inside terms have the same product, negative 6x. And last, we have negative 3 times negative 3, which is plus 9. And I still have this factor out here, 2x minus 3, waiting patiently. Before I continue multiplying, I'm going to combine like terms here. Negative 6x minus 6x gives me negative 12x plus 9. Now we have the situation where we're multiplying a trinomial times a binomial. Well, we're going to apply the same principle. I'm going to take the first term of my trinomial and distribute it to each term of that second binomial. So 4x squared times 2x gives us 8x cubed, and 4x squared times negative 3 gives me negative 12x squared. Okay, once we're done distributing that first term, we're going to proceed to the second term and distribute it to each term in our binomial. Negative 12x times 2x gives me negative 24x squared, and negative 12x times negative 3 gives me plus 36x. We have one more term to distribute here, that's 9. We're going to distribute it to both terms in the binomial. 9 times 2x is 18x, and 9 times negative 3 is negative 27. And we'll finish by combining like terms. So we begin with our highest powered term, 8x to the third power. Then we're going to combine our middle terms here. Negative 12x squared minus 24x squared. That gives us negative 36x squared. Combining our x terms, we have 36x plus 18x. That gives us plus 54x. And our constant term, negative 27. So again, the principle is to make sure every term gets multiplied by every term. Finish by combining like terms and writing in descending order.